All right. Good day, everyone. Welcome to our YouTube lessons. The analogous here. Um, I'll be talking about this set of questions that normally reoccur during the UTME or exercise, because the UTME exam is fast approaching for the 2026 candidate, and it's a question that we can all use to learn. And it's usually on the area of chemistry I'm talking about is mainly the calculations on Gay-Lussac's law, Faraday's law of electrolysis, and some others more concepts and other stoichiometric relationships. Okay, and I would like to look at this very first question, which says, question one here, which says, now 100 cm cube of hydrogen gas is made to react with 50 cm cube of oxygen gas. Pardon me, 100 cm cube of oxygen gas is made to react with 50 cm cube of hydrogen gas. And the whole reaction mixture was then passed through anhydrous calcium chloride. What volume of oxygen gas is left? What volume of oxygen gas is left? Now, quickly, for this kind of simple question, now there are some keynotes. There are some keynotes in this question, which says 100 cm cube of oxygen gas is made to react with 50 cm cube. Okay, I should not be thinking as a good student, this should be Gay-Lussac's law because it has to do with reaction or combination of gases. Okay, what the Gay-Lussac's law states? Gay-Lussac's law says when gases which do chemically react, which do chemically react are combined together, they do so in ratios of their volumes and also with the volumes of the products. Okay, now gases will react. Okay, let's just see if it could be stoichiometry or any other question. Now and the whole reaction mixture was then passed through anhydrous calcium chloride. Calcium chloride is a desiccant, it's going to dry something. Okay, and what is the volume of gas left? Okay, this confirms that the question is on Gay-Lussac's law. So when you are asked a question and you see what is the volume of gas left, especially those of us in UTME and post-UTME level, what is the volume of gas left? Or what is the total volume of residual gases? Gay-Lussac's law, especially when the gas have been made to react or when the gas has been sparked. So you could have seen it's sparked with, but yeah, it's reacted with. It's made to react with. So for Gay-Lussac's law, oxygen is combining with hydrogen in this question. I underline the key points in the question. Also, this is also another key point I'm coming to explain. Now, oxygen is reacting with hydrogen. So hydrogen gas reacted with oxygen gas and you have water vapor. Quickly, now since we have water vapor, we need a balanced equation. So to balance this equation, I'm going to put 2 here. I'm going to put 2 here. If you don't understand, pause and check if the reaction is balanced. Now, according to Gay-Lussac's law, 2 volume of this guy is going to react to 1 volume of this guy in cm cube or in dm cube as your unit will be. Now, for Gay-Lussac's law, this and this is meant to react, and this is going to be formed. Now, before reaction, we do this certain rituals for Gay-Lussac's law. We just say before reaction or before spark, what was the quantity that was made to react? 100 cm cube of oxygen is made to react with 50 cm cube of hydrogen. So therefore, it means that before reaction, 100 cm cube of oxygen is made to react with 50 cm cube of hydrogen. Okay, and usually the products are usually not given before reaction because before the reaction the products are usually not formed. Now, another thing we need again is what are the masses that will be produced, or rather, pardon me, what volume of gases or what volume of each of the reactants or products will be produced after the reaction. Now, obviously, we need to now know the requirements here. Now, for instance, what I mean, now there's what we call excess and limiting reactants in chemistry. Now, for instance, now because it is volume, simple ratio, if you take 50 cm cube of hydrogen, which is 50 cm cube of hydrogen, how many cm cube of oxygen will you be made to react with? What do I mean? The standard reaction ratios is 2:1. 2:1. Now, therefore, it means that 50 will require 25. And come to think of it, if 50 of this guy after reaction requires 25, what was given for oxygen, is it up to 25? Yes, and even more. It means that oxygen is excess and hydrogen is limiting because 50 has to react to 25. And what was given for this guy is way, way, way above 25. It means that oxygen is excess and hydrogen is limiting. So the limiting reactant usually determines the ratio. Okay, now we can, what's it called? We can actually not test for the other guy, oxygen. Now, let's say something now. Let's say 100 cm cube of oxygen is the standard. So 100 cm cube of oxygen, remember it's 1:2. 100 cm cube of oxygen will require 2 volume. That means 100 cm cube of oxygen require 200 cm cube of hydrogen on standard condition, 1:2. And what was given for oxygen was just 50, and I require 200. It means that this guy is excess, because if he's taking as standard, the amount of this guy that will be used will not be enough. The amount of this guy used will not be enough compared to what is given. So it means that oxygen is going, so pardon me, it's meaning that hydrogen is going to be excess. Okay, now if hydrogen is excess, it means that hydrogen will determine, pardon me, oxygen is going to be excess, my bad. Oxygen is going to be excess because, as I said earlier, 50 cm cube requires 25, and we have way above 25 for what was given. So oxygen is excess, hydrogen is limiting, and the limiting reactant determines the ratio. Remember, it's 2:1:2. So 50 will require 25, and 25 will require 50 cm cube. What is now the volume left? What is now the volume left? The volume left, or the residual volume, is going to be, just do a simple subtraction. 50 away from 50, you have 0. So at the end of the day, all the hydrogen gas were used up during the reaction. That's why it is the limiting reagent. Then what is the volume of oxygen left? The volume of oxygen left is going to be 75. So 25, that's 100 minus 25, 75. Now what is now the volume of water form? 50. 50 minus nothing is going to be 50. So the volume of, what's it called, of water vapor left is going to be 50. The volume of oxygen left is going to be 75. Volume of hydrogen is 0. What is the total volume of remaining gas? Is 75 plus 50, which is 125. That's the total volume of the remaining gas. But there is a key factor. There's a key factor in this video. There's a key factor. Now, the question says the mixture was passed through anhydrous. So during the reaction, as the product is formed, you pass it over anhydrous calcium chloride. Anhydrous calcium chloride, I said earlier, is a desiccant and can dry water vapor. So if water vapor is dried, it means that this guy will be dried by calcium chloride. So what is now the volume of the remaining gas? The volume of the remaining gas will just be that of oxygen, which is a 75 cm cube of oxygen gas. That is the volume of the remaining gas. That is the volume of the remaining gas.